episode of Mr. Avila Physics. In today's episode, we're going to talk about accelerated motion. Let's start by defining acceleration. Acceleration is defined as the change in velocity over time. Since velocity is a vector quantity, there are two ways that we can change velocity. We can either change its magnitude or we can change its direction. And by changing either of these two characteristics, then that object would be accelerated. In formula form, acceleration is equal to the change in velocity over time, which means that acceleration is therefore a vector quantity, so it has a magnitude and it has a direction. So here we can see a car starting at time 0 with velocity 0, accelerating at 15 kilometers per hour per second. So this means that his velocity is changing by 15 kilometers per hour every second that goes by. So after 1 second, the velocity is 15. After 2 seconds, the velocity is 30. After 5 seconds, the velocity is 75. After 6 seconds, the velocity is 90 kilometers per hour, and so on and so forth. So let's look at this example here. A person walks on a straight track at a constant 10 meters per second. Is she accelerating? Pause the video here, think about this question, and come back with an answer. So, a person walks on a straight track. That means that her direction is not changing at a constant 10 meters per second. So the magnitude of her velocity is not changing and her direction is not changing, which means that this person is not accelerating. Let's look at this next example. Now, the same person walks on a circular track at a constant 10 meters per second. Is she accelerating? Pause the video here, think about this for a little bit, and then come back. All right, welcome back. So, if the person is walking in a circular track at a constant 10 meters per second, so here we see that the magnitude is not changing, but what about her direction? As she moves along the circular track, the direction of her velocity is changing, which means that since the velocity is changing, then this person accelerates. All right, let's move on. A driver sees his speed as 5 meters per second. He then at the same time accelerates and starts a timer. At the end of 10 seconds, he observes that his speed is now 35 meters per second. What is his acceleration? All right, pause the video here. Think about this for a couple of minutes and see if you can come up with an answer. All right, welcome back. Now earlier we had defined acceleration as the change in velocity over time, right? So to find the change in velocity, we're going to do final velocity minus initial velocity over time. So here we have his final velocity, which is 35 meters per second. His initial velocity is 5 meters per second. And the time to do this is 10 seconds. So by solving this, we have 30 divided by 10. So his acceleration is 3 meters per second squared. And since the velocity increased, then the acceleration is positive. All right. Now, what if we want to find more information, not just the acceleration? We want to find information about how far did the car move in a given time interval while accelerating. Or we want to find out how long it took an accelerated car to cover a certain distance. Now, to do this, we have a set of equations that are known as the kinematic equations. These equations can only be used if the acceleration is constant. So if the acceleration changes, then these equations cannot be used. But for this course, we're going to be dealing with constant acceleration, so we're going to be able to use these equations. The kinematic equations are as follows. First, we have final velocity is equal to initial velocity plus acceleration times time. So Vf is final velocity. Vi refers to initial velocity. A refers to acceleration, and T refers to time. Our next formula is x is equal to VIT plus 1/2 AT squared. X refers to displacement. Not distance, but displacement. Remember that in a previous video we mentioned that if an object moves in a straight line without changing directions, then the terms speed and velocity, or distance and displacement, are also interchangeable. Our next formula is Bf squared is equal to Bi squared plus 2AD. Once again, distance, displacement, they're interchangeable. This is also displacement. So d or x referred to as displacement. And our last equation is average velocity is equal to final velocity plus initial velocity divided by 2. And this right here are the 4 kinematic equations that can be used to analyze any problem with uniform constant acceleration. Let's look at some examples, shall we? So, a sprinter accelerates from rest to 9 meters per second in 1.38 seconds. What is her acceleration in meters per second and kilometers per hour? That's actually, we can forget about B, but we'll do it here. So let's see what information we have. The sprinter accelerates from rest. Rest means that you are initially not moving. Okay, so we know here that the sprinter's initial velocity would be 0 meters per second. We know that final velocity is 9 meters per second. We know the time it took to change its velocity from 0 to 9 is 1.38, and we are trying to find the acceleration. Based on the information given, I'm going to go ahead and say that final velocity is equal to initial velocity plus AT. So 9 is equal to 0 plus 1.38a. That means that a is equal to 9 divided by 1.38, and that gives us an answer of 6.52 meters per second squared. All right, let's look at our next example. At highway speed, a particular car is capable of an acceleration of about 1.8 meters per second squared. At this rate, how long does it take to accelerate from 65 kilometers per hour to 120 kilometers per hour? Pause the video here, take a couple of minutes, and see if you can solve this example. When looking at this, be very careful about our units. Acceleration is in meters per second, and our velocities are in kilometers per hour. It's a little hint for you. while you work on this example. All right, welcome back. Well, as we usually do, first we realize what information do we have. So we know that the acceleration is 1.8 meters per second squared. We know that the initial velocity is going to be 65 kilometers per hour, and the final velocity is going to be equal to 120 kilometers per hour. And they're asking us how long is a measure of time. So they're asking us to find time. All right, the first thing we have to do is, of course, make sure that everything is in the correct units. So we can do one of two things. We can change the acceleration to kilometers per hour, or we can change the velocities to meters per second. Now there is a good trick that works. If we want to go from kilometers per hour to meters per second, we divide by 3.6. So this means that 65 kilometers per hour would be equal to 18.06 meters per second. And 120 kilometers per hour would be equal to 33.3 meters per second. So now we can solve this problem. So if I want to solve this problem, then just go ahead and say, all right, so I have final velocity, initial velocity, and I have acceleration, but I need time, so I will be using this formula. Final velocity is 33.3, initial velocity is 18.06, plus acceleration is positive 1.8, and solving for time, which means that time is going to be equal to 33.3 minus 18.06 divided by 1.8 gives me an answer of 8.49 seconds. 8.49 seconds. So that means that it's going to take this car 8.5 seconds to go from 65 kilometers per hour to 120 kilometers per hour. All right, let's look at our next example. A car slows down from 28 meters per second to rest in a distance of 88 meters. What was its acceleration? Assumed constant. So the car slows down from an initial velocity of 28 to a final velocity of 0 in a distance of 88 meters. So that means that we have information of, we know its initial velocity is 28 meters per second. We know the final velocity is 0 meters per second. We know the distance is 88 meters, and we're trying to find the acceleration. Based on the information that we have, there's only one of the kinematics formula that we can use, and that formula is Pf squared is equal to Pi squared plus 2At. So Pf squared would be 0 squared equals 28 squared plus 2 times 8 times 88. That means that negative 28 squared divided by 2 times 88 will equal A. So acceleration will be equal to negative 28 squared divided by 2 times 88, 4.45. So an acceleration would be equal to negative 4.45 meters per second squared. This means, since we got a negative acceleration, this means that the car is slowing down, which is the situation in the problem, so it makes sense. All right, let's look at our next example. In coming to a stop, a car leaves skid marks 65 meters long. Skid marks are the marks left by the tire on the pavement when a car slams on the brakes. Same way that if you're riding your bicycle and you hit the brakes and the tire leaves a black mark on the sidewalk, those are known as skid marks. Assuming a deceleration of 4 meters per second squared, estimate the speed of the car just before braking. Pause the video here, take a couple of minutes, and see if you can come up with an answer. All right, welcome back. Now, reading this problem, we can see that the car came to a stop. That tells me that the final velocity is 0. The car leaves marks 65 meters long. That means that the distance traveled while stopping is 65 meters. Assuming a deceleration. Deceleration means that you're slowing down. And then estimate the speed of the car just before braking. So the information that we have is final velocity is 0. We know the distance is 65. We know the acceleration is negative 4 meters per second squared because we are slowing down, and they're asking us if we can find initial velocity. So based on the information that we have here, then we can only use, or the fastest way to solve this is by using this formula right here. Bf squared is equal to bi squared plus 2at. 0 squared is equal to bi squared plus 2 times negative 4 times 65, which means that bi squared is equal to 520, which means that the initial velocity is equal to plus minus square root of 520, which is, give me a second here, square root of 520, which is 22.8. So algebraically, we have to do the plus or minus, but only one of these answers makes sense, okay? And that would be positive 28. Thank you for watching, okay? Hopefully the examples made sense and you are able to now use the equations for kinematics. All right, see you next time.